Welcome to Fluticasone Propionate Suspension Meter Dose Inhaler, Plasma Treated Canister Performance and other canister types. I'm Dave Lewis. I'd like to thank my co-authors Rob Johnson and Daniel Lewis from Oz UK Limited in Chippenham UK and Jackie Green from H&T Presspart, Blackburn UK. The key message in this presentation is that a Fluticasone Propionate HFA-134A suspension formulation has been evaluated in 5 alternative canister types. No significant difference was observed in the drug delivery performance or residual drug total can content for plasma-treated or FEP-coated canisters, both of which outperformed non-coated canisters. It has been reported that adhesion of suspended micronized drug particles to the pressurized meter dose inhaler canister walls may result in deviation of the inhaler from label claim. Controlling canister surface and drug interaction via robust engineering processes of medical devices has previously been highlighted, emphasizing that plasma-based technologies can outperform more conventional coating methodologies. In this study, micronized fluticasone propionate was suspended in HFA-134A and packaged within 5 alternative canister types: fluorocarbon polymerized FCP plasma treated, anodized, fluorinated ethylene propylene FEP coated, stainless steel and aluminium. Chemical stability data and in vitro drug delivery were obtained following valve up and valve down storage at 40 degrees C and 75% relative humidity. Chemical stability of fluticasone propionate was determined at initial, 1 month and 3 month time points. Fluticasone propionate in vitro drug delivery was determined at the initial and 3 month time point. Meter dose inhalers were manufactured utilizing fluticasone propionate that was micronized in-house using a small scale air jet mill. Between 17.8 and 18.4 milligrams of micronized fluticasone propionate was added to each canister. All meter dose inhalers were fitted with Aptar DF316 61 microliter metering valves. Valves were crimped to the canisters, and between 10.8 and 11.2 grams of HFA-134A was added to each can prior to dispersion by ultrasonication. Quantification of fluticasone propionate within test samples was quantified by HPLC. Fluticasone propionate chemical stability. The chemical stability of fluticasone propionate was evaluated in duplicate after 1 month storage upright and inverted at 40 degrees C and 3 months storage upright and inverted at 40 degrees C, 75% relative humidity. The initial drug residual can content N equals 12 immediately following manufacture was determined to be 99.3 plus or minus 1.7% of the target value for all canister types. This table presents the fluticasone residual can content following valve up and valve down storage. Results of an average of duplicate measurements. At both 1 month and 3 month time points, the residual masses observed for valve up MDIs were 100 plus or minus 1%, pooled results relative to time 0. This indicates that canister choice has little effect on the chemical stability of the fluticasone propionate suspension. With the exception of stainless steel and plain aluminium canisters, data was also consistent at both time points for canisters stored valve down. Stainless steel and plain aluminium canister drug residual values were low after 3 months valves down storage at 92% and 93% respectively. Drug delivery data in vitro was determined for plasma-treated canisters and FEP-treated canisters and plain aluminium canisters at both initial and following 3 months storage at 40 degrees C and 75% relative humidity. Results were obtained in triplicate using a next generation impactor sampling at a flow rate of 30 litres per minute. Shot weights were consistent for all doses fired during the study, 78 plus or minus 1 milligram. At the initial time point, no significant difference was found in the drug delivery metrics for the three can types investigated: plasma-coated, FEP-coated and plain aluminium. Particle size distributions were observed to be consistent for all canister types, grouped MMAD equal to 3.4 plus or minus 0.2 micrometers. Following 3 months storage of 40 degrees, 75% relative humidity, valve up, the surface treated canisters were observed to maintain a meter dose close to the 125 microgram target. However, the observed meter dose for meter dose inhalers packaged in uncoated aluminium canisters dropped to 86 plus or minus 9%, indicating a drug loss of 2.5 plus or minus 1.6 milligrams to the wall of the plain aluminium uncoated canister. Fine particle dose and fine particle fraction was observed to be lower for all MDIs following 3 months storage at 40 degrees 75% relative humidity. MAD is also seen to increase. This change in physical nature of the suspension has been reported to be a result of moisture ingress during a 3-month 40 degrees 75% relative humidity storage period. The drop in fine particle dose and fine particle fraction can be limited by pertinent selection of sealing gasket materials and controlled manufacturing conditions. See references 4, 5 and 6. When compared to Flixotide, which had a fine particle dose of 44 plus or minus 5 micrograms, no significant difference was observed in the fine particle dose for plasma-treated canisters and FEP-coated canisters following the 3-month storage period, 40 degrees 75% relative humidity, valve up. However, significant difference was observed for the uncoated plain aluminium canister following 3 months storage. Fine particle dose was 33.5 plus or minus 1.1 microgram. In conclusion, the data presented in this study highlights the importance of selecting a suitable canister type during formulation and product development. For the fluticasone propionate formulation evaluated, surface-treated canisters outperformed plain stainless steel and plain aluminium canisters. Fluticasone propionate total can content was observed after 3 months valve-up storage at 40 degrees 75% to be close to 100%. Drug delivery performance following 3 months storage of 40 degrees C and 75% relative humidity showed no significant difference in performance of plasma-treated canisters and FEP-coated canisters. Both outperformed plain aluminium canisters. And here are the references cited throughout this abstract. I would like to thank Drug Delivery to the Lungs for this opportunity to present, and I'd like to thank you for watching, and if you need any more information, please contact us on the email address on this slide, either Oz UK Limited or Presspart.